Yes, class. Anyone getting me, please? I just want to know whether these people are in class. Mary Mwing, because I need to take attendance very serious. Derek Okonyi, they're not in class. Onunga, not in class. Because if I call your name and you don't get it, and then it means you're not in class. So I'll just immediately remove you from this conference. Derek? Victor?
Yes, sir.
Yes, where did we end our class last week?
I think we were studying about output devices, of which I think we ended about that device.
Pardon?
We were studying about output devices.
And where did we end? Yes, Victor.
I think we summarized it up to 10.
So today's class, are we comfortable to start from memories?
Yes, sir.
Okay.
Of which you had promised us to start there.
Okay. Now I can proceed and start from memories.
Yes.
Now I want to say that you have your notes, class notes, please. Let me know. You have your class notes? Victor, do you have your class notes?
No, personally, I don't have notes, sir.
But I shared the notes. Maybe you can check from your colleagues because I'm not able to access my notes. So,
okay.
Yes, I'm not able to access any of my materials now, so I'll just proceed with the class.
Okay, sir.
So I wanted to begin from memories, and I would want to just remind you when it comes to the term memories, you've come across memories before. And when I talk about memories, I mean storage. These are the main storage devices in a computer. I know earlier on, you might have come across different types of memories, like memory cards that you've been using day to day. We have flash drives, flash disks, and even computer hard drives. You must have come across these memories. It's not something new to you. What just I want to extend is that the way data is stored in memories is inside sections known as cells. So that you need to realize and understand that memories have been sectioned into cells or locations known as cells. So that, for example, if I give you a 64K word, for you to compute the number of memory location in a 64K word, you will multiply by 1024. I'm talking about 1024 here the first time. You will come across 1024 later on when we'll be doing other computations, but it is one of the standards that is used for computation of storage or memory locations. So if I am given 64K word, then I mean 64 multiplied by 1024. It gives me 65,536. That is to compute the number of locations or memory locations or cells in that regard. Remember I said memories are subsectioned into cells. So when I say 64 multiplied by 1024, I will get 65,536 minus 1. Why am I saying minus 1? Memories range from cell 0 to cell 65,535. Remember, when you multiply, you will get 65,536, but you need to consider memories just work like indexes. It begins from index 0 to that particular index. So you need to understand that memory location is equals to memory size minus 1. And you have seen that computation. That 64 multiplied by 1024 is 65,536 minus 1. It gives you 65,535 memory locations. Now, memories are subdivided into three: cache memory, primary memory, and secondary memory. Now, I'll begin from cache memory. Cache memory is a very high-speed semiconductor memory. When I say semiconductor, it means it is made up of semiconductor materials. And that is what makes this cache memory to be very high-speed memory. Now, this is the working memory of the CPU. When I say working memory, I mean this is a memory which is directly accessible to the CPU. CPU directly accesses the cache memory. It is the working memory of the CPU, as I stated. So you need to understand that cache memory is very high speed memory, very also in terms of storage size, it's very small, because only it is required to just hold the contents that is being accessed by CPU at that time, temporarily. So you should be able to understand cache memory to mean that it is a type of memory which stores data temporarily. Now, the other one is primary memory. Yes? Any question, Rafael, and a query? Yes, if there's no question, I continue. Primary memory. Yes? I think there's a question from Rafael. Rafael, can you come up clearly? Yes, Rafael. We can't get you. Maybe it's because of a connection. Maybe you can bring the question at the end of towards the end, please, so that we can continue with the lecture.
Okay.
Yeah. So we were talking about the primary. Let's be meeting once you enter the class, please. Now, primary memory, on the other hand, again, is regarded as the memory which is a fast memory. It is also made up of semiconductor materials. And I want to say that the way the CPU accesses the primary memory is via I/O routines, or what we say input-output routines. So it is not as fast as registers. We have memories such as registers, which is directly accessible again to the CPU. So we want to say that primary memory is not as high speed as registers, but it is accessed by the CPU via input-output routine, via input-output routines. And we say the way the CPU accesses it is the operating systems gets to load the data and programs required to be accessed. So it is the function of operating system to load this data and programs to where it is now accessible to the CPU for processing. Now, examples of this primary memory include RAM and ROM. You must have come across RAM and ROM before. Read-only memory and random access memory. Now, from the word read-only and random access, what we mean is that read-only memory is a category of memory whereby you can only read, but you cannot, when I say ROM, it's only read, but you cannot write, meaning that its contents cannot be changed. So we later on discuss on ROM. RAM, on the other hand, is random access memory. It is a type of read-read memory, meaning that its contents is changeable. So the contents of RAM can be changed, but the contents of ROM cannot be changed. Again, yes. No, Kefas, we are in yesterday's class. I think there's a question being posted by Kefas. This is a class equal to the class we did yesterday. So it is not an addition to yesterday's class. So that is it. So I was talking about RAM, and I said RAM is volatile while ROM is non-volatile. To mean that when I say volatile, if electricity goes off, it loses its contents. Remember, I said it is a read-write memory, which means you load content and that content is accessible or processed at that time, and then it is over. But on the other hand, ROM, you program those data and instruction permanently to that ROM chip. So you see, that's why we could classify ROM as read only. I hope that is clear. I'll later on go to independently to deal with RAM and ROM. The next one is secondary memory. Now, this is a class of memory also known as external memory, which is used to store data permanently in a computer. Examples of these external memories: hard drives, flash disks, memory cards, and all the ones you know. This, I would say that it stores data or information permanently. So whatever is stored in a flash disk, you don't expect it to change. It is not like the way you would store in a RAM, and when electricity goes off, it disappears. So I would want to say this is a form of storage which stores data permanently. It is also known as external memory. So I hope we are very clear now about the three types of memories: the cache memory, the primary memory, and the secondary memory. Now I want just to mention about RAM again. As I've said, RAM is a random access memory, and it is a very high speed memory, but it is meant to store data that is currently being worked on by a computer. And I said we have two types of RAMs: static RAM and dynamic RAM. See, so when I talk about static RAM, and I would want just to talk about in terms of the implementation of it, so that you can be able to distinguish between the two. So in static RAM, it is made up of 6 transistors and no capacitor. You see? So this static RAM in itself, it doesn't store any charge. Remember, I want to put across a point here, that the way information is actually stored on memories, in real sense, in a practical sense, is in form of charges, electric charge. So that if I trap an electric charge, it means an instruction such as 1. If I don't trap an electric charge, it means 0, like that. So when I'm explaining about this RAM in general, I would want to say that, as I have said, RAM, this type of static RAM, it's made up of 6 transistors and no capacitors. So the use of capacitors actually is to store charges. That's what makes this RAM that is to make it volatile, is because of lack of a capacitor, which doesn't store any charge. The other one is dynamic RAM. Dynamic RAM is made up of 1 capacitor and 1 transistor, which makes it a little bit store some content for some few data. So you realize that dynamic RAM is non-volatile, owing to the fact that it has a capacitor. And you know what is the use of a capacitor from physics class. So you will be able to read on the other characteristics, advantages and disadvantages. So the other one is ROM. I want to explain about ROM, read-only memory. Now, this is a memory where you can only read, but you cannot write. So as soon as the instructions have been programmed to a ROM chip, it cannot be changed. It is not changeable. So owing to the nature of ROM, whereby you predefine the instructions going to the ROM chip. So I would want to explain the different types of ROM chips, starting from MROM, Eeprom, Eeprom, and the other one is Eeprom. So I'll start from an MROM, masked ROM, and I want to say these ones were the first kinds of read-only memories, which were made up of hardwired devices. So if I do a wire wiring. In that regard, have a hardwired, it means 1. Then there's no hardwired device or connection, it means 0. You see? Remember, instructions in a computer are identified in form of just in form of electric charge, or in form of I would just want to put a fuse. If you have seen a fuse, if I have a plain fuse, it means 1. If I burn a fuse, it means 0, like that. That's how you put instructions into an electric device as such. So I would want to say instructions are in form of logical 1 and 0. So I was talking about musket ROM, and I said musket ROM were the first kinds of ROM, and they were made up of hardware devices. The next one is Eeprom, programmable read-only memory. So that this kind of memory was actually made of fuses. It is made up of fuses. When you burn a fuse, it means 0. You don't burn a fuse, it means 1. I burn another fuse, 0. I don't burn a fuse, 1. That means 1, 0, 1, 0, 1, which could be referred now as 21. If you want to consider it in a decimal format or in a format which is a human readable, you could refer that one as an instruction number 21. When I say 1, 0, 1, 0, 1. So you burn a fuse to mean that you want to put 0, like that. Remember, instructions in a computer is in form of 1s and 0s. So I was talking about Eeprom, and I said it is made up of fuses. The other one is erasable, programmable, read-only memory. Now, this one uses ultraviolet light. You realize that in this one, you trap an electric charge in an insulated gate region. Once you trap an electric charge, it means 1 or an instruction. When you don't trap, it means 0. So trapping an electric charge in an insulated gate region means you are putting an instruction. But this one now, it uses ultraviolet light, or what you say UV light, to erase. And that process of programming and reprogramming is achieved by Eeprom eraser, or Eeprom eraser in that regard. So the other one is Eeprom, electrically erasable, programmable, read-only memory. If you compare with the other one, I said on Eeprom, we just said Eeprom, then that one uses UV light. But now this one, you've seen, we started by saying electrical. So it is electrically programmable read-only memory. This one is using electricity. So that process of programming and reprogramming is actually done by using electric charges, as opposed to the other one, which was using UV light. So with that, I would want to say that I have given you an highlight on memories, so that you can be able to pick from memories from the next chapter. So I'll be able to inform you on the next chapter, which you ought to pick from. So if you have your manual, you can be able to follow and know which chapter you're supposed to go next. Maybe if someone has notes, you can tell us where we are supposed to pick from.